This video covers the overview page of the ACEP Premium Access portal. The overview page provides a consolidated, real-time representation of the spacecraft's global operational state. It aggregates mission progress, temporal references, system health indicators, event history, and spatial context into a single interface. The function of this page is general situational awareness. It allows rapid assessment of mission status. The header is identical across all pages. It displays the current mission timestamp on the left side. The menu bar provides direct access to all telemetry domains. The logo opens the 1G Space website, and the account link provides access to subscription management. The primary panel provides a rapid health check and lists the primary mission parameters. Distance and duration report progress fractions along the planned trajectory. Distance traveled and distance remaining report completed and remaining path length. True speed reports current spacecraft velocity in the proper frame. See navigation page for detailed kinematics. Gross mass reports instantaneous total spacecraft mass. Fuel remaining is reported for proton-boron 11, antiprotons per core, and metallic hydrogen as remaining amount and fraction. See propulsion page for detailed fuel state and flow. DSIM-CAFR reactor, Core 1 and Core 2 load. Report the fraction of rated reactor power carried by each core. Waste heat reports rejected thermal power. Heat to energy reports recovered electrical power. Radiator usage reports active heat rejection per radiator train. Heat radiated used reports the fraction of total waste heat rejected through the radiators versus the fraction recovered and converted into usable electrical power. See energy page for full thermal and electrical balance. Memory array usage reports onboard data accumulation. See AURAI for storage detail. UPS SSB charge reports battery reserve state, including degradation and state of health as a fraction of initial capacity. MSAD statistics report cumulative debris interactions and the annihilation versus deflection fraction. See survey page for debris environment and event context. ACEP Atmos status reports current state and mode of the atmospheric probe. The Gen State panel shows the primary mission and system parameters as normalized values. It is used for rapid trend and imbalance detection. All bars are scaled for direct visual comparison. The Time panel defines all temporal reference frames used throughout the system. Earth regional clocks provide civil time context. Mission elapsed time and the spacecraft clock report time in the spacecraft proper frame. Delta T reports accumulated divergence between Earth time and spacecraft proper time. SCOGI-TOX Next TX reports time to the next scheduled transmission window. See the connectivity page for details. ACEP Atmos release reports countdown to the scheduled atmospheric probe separation event. EOC, or end of cruise, marks the transition from continuous powered flight to post-arrival operations, at which point ACEP completes deceleration and enters stable orbit at the destination. UPBC reports the current Universal Proxima B calendar timestamp. TCT, ESST, and ESRT report Proxima B orbital phase time references within the same calendar system. See the manual page for definitions. The System Events panel lists mission events in reverse chronological order, providing context for system behavior and mission progression. Each entry is time-stamped in spacecraft mission time and color-coded by severity. Events include debris encounters, mission milestones, and contextual reference entries derived from current flight conditions. The Mission Situational Awareness Display provides a three-dimensional, continuously updated representation of the mission state in space. It combines trajectory geometry, spacecraft attitude, navigation error, and astrophysical context into a single spatial view. MSAD is used to understand where the spacecraft is, how it is moving, and how it is oriented relative to the planned trajectory and surrounding sky. All elements shown in this display are driven by live mission telemetry and are synchronized with the navigation and timing systems. The Unit menu controls the distance scale used for the display geometry. The View Mode menu defines the viewing mode, displayed layers, coordinate overlays, and visualization context. The Statistics box provides numerical readouts required to interpret the displayed geometry and motion. The Unit menu selects the distance scale used to display the trajectory gates. Available units are astronomical units, lunar distances, 1,000 kilometers, and kilometers. The selected unit defines distance labeling and gate spacing along the trajectory. Gates represent fixed distance intervals and are drawn ahead of and behind the spacecraft. Gate shape and color encode the active unit. Gate labels display numeric distance in the selected unit. Kilometer and 1,000 kilometer modes are disabled during most of interstellar cruise due to limited readability. The display automatically transitions to the most readable unit based on spacecraft velocity. This ensures consistent spatial interpretation across all mission phases. The Mode menu is organized into multiple vertical columns that control the viewport, sky rendering, display options, and overlays. Selected viewport types impose specific constraints on the available rendering modes and options. Some functions in this menu are disabled on mobile devices. In Environment mode, the display is centered on the spacecraft's nominal position along the planned trajectory. The magenta line represents the ideal planned trajectory. The orange line represents the actual flown trajectory. The dashed orange segment indicates the predicted future trajectory based on the current navigation solution. The green vector shows the deviation from the ideal trajectory, including both direction and magnitude in kilometers. Red axes attached to the spacecraft marker show the current ship orientation. The camera can be rotated around the scene, while zoom is controlled with the mouse wheel. Ship Zoom mode centers the camera directly on the spacecraft. The surrounding sky and trajectory geometry remain unchanged. This mode increases local spatial resolution, making the spacecraft, deviation vector, and nearby gates easier to interpret. Additional display options are available in this mode that are not enabled in other viewports. Mouse rotation and wheel zoom remain available within limits. Telecam mode switches the view to the onboard telescopic camera reference frame. Camera motion is constrained by the physical mounting and pointing limits of the instrument. Rotation commands map to telecamera azimuth and elevation. Zoom reflects changes in camera field of view. Sky rendering modes. Synthetic renders a catalog-based stellar sky using discrete point sources with spectral coloring. Star positions are computed from astrometric catalogs and represent precise angular geometry without background emission. Visible SD renders a low-resolution optical sky background representing integrated visible light emission of the Milky Way and large-scale dust structure. Visible HD renders the same optical background at higher spatial resolution, revealing finer dust lanes and stellar density gradients. Gamma Phot renders a high-energy photon count sky map. Point sources and statistical photon noise are preserved, allowing relativistic aberration and forward compression to be observed directly on discrete events. Gamma diff renders a smooth, diffuse gamma-ray emission model. This mode emphasizes large-scale galactic plane structure associated with cosmic ray interactions. X-ray renders a soft X-ray sky background dominated by emission from hot plasma, supernova remnants, compact objects, and other high-energy astrophysical processes. FAR-IR renders thermal infrared emission from interstellar dust. Brightness variations reflect dust temperature and column density, highlighting galactic cirrus in star-forming regions. CO10 renders the distribution of molecular gas traced by the carbon monoxide rotational transition, highlighting dense molecular clouds and filamentary structures linked to star formation. The percentage box shows background imagery download and loading progress. The options controls. Labels controls the display of object names and identifiers within the scene. When telecam mode is active, enabling labels or any overlay also activates camera reference grids in the viewport. These include the local azimuth elevation grid of the telecamera and a celestial coordinate grid. The grids are aligned to the telecamera bore site and provide precise angular and astronomical context for object identification and pointing verification. Relativistic mode enables a physically consistent special relativistic transformation of the sky in spatial context, allowing direct visual correlation between spacecraft velocity and relativistic observables. When active, all sky geometry is transformed using the full relativistic aberration formulation, progressively redistributing angular structure toward the forward direction of motion. Stellar radiance is modified by Doppler shift and relativistic beaming, producing systematic forward amplification and rearward attenuation as spacecraft speed approaches relativistic regimes. Non-optical sky layers undergo the same aberration transform to preserve geometric consistency. The telecam's celestial coordinate grid is also affected by relativistic effects. Ship orient mode aligns the viewport reference frame with the spacecraft body orientation. Overlays modes. Celestial Chord displays a celestial coordinate grid projected onto the sky sphere, providing angular reference in standard astronomical frames. The grid geometry responds to relativistic aberration when relativistic mode is active. Constellations displays constellation figure lines and boundaries derived from standard stellar catalog definitions. Constellation geometry is transformed consistently with the relativistic sky model. Trajectory controls the visibility of the geometric mission overlay. Disabling this overlay suppresses all trajectory-related geometry without affecting sky rendering or camera orientation. The spacecraft model reflects the live, physical state of ACEP. Model position and orientation follow real-time navigation and attitude telemetry. Radiator surfaces emit color corresponding to their current temperature in Kelvin, visualizing heat rejection. Scogitox emitter pods update their orientation dynamically in real time. The ACEP Atmos probe is shown docked prior to release and follows its predicted trajectory after separation. The plasma exhaust plume scales in length and intensity with current reactor load. Event markers annotate mission events directly on the trajectory. Scheduled events are shown on the ideal trajectory, while spontaneous events are shown on the actual trajectory. Marker position encodes event timing and location, and marker color encodes event category and severity. The stats box provides numerical readouts corresponding to the current MSAD view. The speeds section reports spacecraft velocity converted into multiple distance and time units for cross-scale interpretation. The position section reports spacecraft attitude and navigation state, including pitch, bank, yaw, estimated position error, and current cross-track deviation. The optics section reports relativistic and observational parameters, including velocity fraction of light speed, Lorentz factor, aberration angles, Doppler and beaming factors, and telecamera pointing. Celestial coordinates of the current view direction are reported simultaneously in equatorial, galactic, and ecliptic reference frames. The stats box provides the exact numerical context required to interpret the visualized geometry and relativistic effects. Summarizing, the overview page provides a high-level, integrated view of the mission state, while the subsequent pages focus on detailed analysis of individual subsystems.